guys, how you going? So welcome to our next video in our video series, and today we're going to be doing a little bit more physics, and we're actually going to be looking at density and density calculations, okay? So what is density? Well, density is actually a measure of how tightly packed particles are in an object. So basically how many particles are sort of crammed into a space, right? With the more particles meaning that effectively it's more dense, less particles meaning it's less dense. In order to measure density, we only need to know two pieces of information: the mass of the object, or how much it weighs, and the volume of the object. So making sure we know effectively how big it is or how much space it fills up. So mass and volume, only two things we need to know. And to calculate density, all we do is we take the mass value, divide it by the volume, and that's the calculations for density. So let's have a look at this. Let's look at two examples. And I'm asking you the question, which is denser, right? A rubber ducky or Donald Trump? I think we know the answer. However, let's give it a go. So in order to work out the density of the duck, we need to know its mass, which is 60 grams, and we need to know its volume, which is 100 centimeters cubed, okay? And so density, remember, is mass divided by volume. So its mass was 60 grams, and its volume was 100 centimeters cubed. So it's 60 divided by 100. So the density of the duck is 0.6 grams per centimeter cubed, okay? Whereas let's have a look at Donald. So let's try and work out Donald's density. Again, it's mass divided by volume. Donald's mass is 110,000 grams, all right? And his volume is 6,500 centimeters cubed. So 110,000 divided by 6,500 means that Donald's density is 16.9 grams per centimeter cubed, okay? By just mass divided by volume. What we can say from this is that Donald Trump is very dense. Well, at least he's denser than a rubber duck, okay? And so this is how we calculate density: mass divided by volume. Now, sometimes these will be different units. The ones I've seen most common in a foundation paper are grams per centimeter cubed. However, that can often be kilograms, and this could be meters cubed, and we can convert between those. All right, so lucky last, you sort of asked me, but sir, how do we work out density? Well, you know, all we need to know is two pieces of information: the mass of the object, which we get by simply weighing it on a set of scales, okay, and the volume of an object. And in order to work out the volume, we submerge it in a eureka can, and the volume of water that gets displaced is the volume of the object. And this is a eureka can here. So if we submerge an object in it, water will flow out, and the volume of water displaced is the same as the volume of the object, okay? So then all you need to do is divide the mass by the volume, and hey presto, you got density. So let's take a strange object. So you get your I Love Science pin out, right? And we needed to work out its density. It's a bit oddly shaped. It's got those curves at the back or whatever. How do we work out its density? Well, first we weigh it. So we put it on a set of scales to get its mass. We then put the object in a eureka can. The volume of water that gets displaced is the volume of the I Love Science pin. So then we just divide mass by volume, and we've worked out density, okay? And this is how we calculate what density is. Hope it helped, guys. I'll catch you later.